All right, working related rate problems, and this is a typical problem you might see in Cal 1 or even just the business calculus. Um, and that's the ladder problem, which I've got some kind of diagram over here. I'll show you here in just a minute. But we got a 16-foot ladder leans against a house. The base of the ladder is pulled away from the wall at a rate of 4 feet per second. So if you're up on the ladder and I don't know who'd be pulling it away, but I wouldn't be very happy about that. But anyway, we'll just deal with it. How fast is the top of the ladder moving down the wall when x is equal to 5 feet? Now, I guess we'll take a look at the picture I've got drawn. Okay, so here's the ladder, 16 foot long. This is your 5 feet have been measured right here, and the wall doesn't quite look vertical, but it's supposed to be vertical. Now if this wall is not vertical, an actual vertical wall right here, this problem wouldn't work, because then we wouldn't have a right triangle, right? And so that would just be a whole lot more interesting problem, which I have a football problem, a quarterback and receiver problem. Hopefully I'll be able to add to this problem set that's really neat. But anyway, we've got dx over dt is 4 feet per second. Now that means that this the ladder at when x is equal to 5 feet, okay, right here at x is equal to 5 feet, right, it's being pulled away at 4 feet per second. Now I guess you could think of, even if x were right here, it's still being pulled away at 4 feet per second. So 4 feet per second is kind of constant all the way across. But we're only concerned about how fast is this. This is the top of the ladder, and it's moving down the wall, right? So how fast is our y changing, right? How fast is the y direction changing? And that's what we're going to be looking at. Now, you should be able to just guess, well, I guess not guess, but you should be able to know, since the ladder is moving down, we know that our dy over dt is going to be negative, right? Because it's decreasing. Okay, the y is decreasing. Our x is increasing. That's the reason that's positive. So let's work the problem out. All right, so this is the general equation. Now this is x squared plus y squared is equal to r squared, right? So that's going to give us the relationship of all the sides of a right triangle. And what we're going to be doing here is taking the derivative of this. So the derivative of x squared is 2x, and then remember we tack on a dx over dt, plus derivative of y squared is 2y, and then tack on a dy over dt is equal to, and the derivative of r squared is just 2r dr over dt. Now r is not changing, right? That would be the length of the ladder. The length of the ladder is staying constant. So that means that this is not changing. This would be 0. Okay, so that makes that whole right hand side of the equation 0, no matter what r is. So we go ahead and plug in everything that they gave us. So they gave us x was 5, so we plug that in. Dx over dt is 4, remember 4 feet per second, and then we have 2y dy over dt, and the dy over dt is what we need to solve for. Now remember that the dr over dt right here, I'm sorry, we need to solve for dy over dt. The dr over dt, remember, was 0, because that's not changing. That's staying constant, therefore it's not changing. And so that's 0. And right, we went ahead and plugged in the r here, but all that's going to end up just being 0. But here's the question: what is y? All right, they never gave us a y, but that's okay, because we'll go back into where x squared plus y squared was equal to 6, or right, r was equal to 16. So we're just plugging this stuff in, and now we can solve for y. So y is equal to the square root of 231, or I've just approximated here to 2 decimal places, 15.20 feet. But we're going to go ahead and use the exact value here, the square root of 231. So now we can go ahead and solve for dy dt, and as you can see here, dy dt is equal to, after getting everything over to the right hand side of the equal sign, and of course I just approximate it. We can better kind of look at that than look at that, right? So I went ahead and just approximated 2 decimal places, and remember it's negative, so that means it's decreasing, negative 1.32 feet per second. Okay.